All right, now we have our last video for our circles unit. It's all about tangent lines. So just as a review, remember a tangent line is a segment or line which intersects a circle at exactly one point. So if you were to draw a circle, something like this, and you wanted to make a line from this point, that would be a tangent. It can only hit it at one point. From that same point, there can be another tangent over on this side. So that would be two different tangent lines. Something else to review, the Pythagorean theorem. Remember, anytime you have a right triangle, the two legs, we'll call them A and B, if you square each of the lengths of those and then add it up, it equals the square of that third leg. And remember, that's called the hypotenuse. So we usually say that as A squared plus B squared equals C squared. All right, we have two different theorems we're going to look at. In a plane, a line is tangent to a circle if and only if it is perpendicular to the radius at the point of tangency. So what that means is this line, if I'm going to start here at C to A, we would only call this a tangent line going all the way across here if this radius that it makes here, if this is a right angle. So if I told you, yep, this here is a tangent line, you know for sure that this is a right angle. If I told you this is a right angle, you know for sure, yep, this is what's called a tangent line. So it goes both ways. Okay, the other theorem to work from is the congruent triangle or congruent tangent theorem. If two segments are drawn from the same exterior point and are tangent to the same circle, then they are congruent. So again, if we have this point right here, we're going to call it C, and we make, I'm going to do one in red. We make one tangent line right here, and then we make another tangent line right here. And we know that these are both tangent to the circle. They intersect just at the one point, and it makes a right angle right there. Then we know for sure this line has to be just as long as this line every single time. It always has to be true. As long as they're coming from the same exact point, then these two tangents are going to be congruent to each other. So let's look at our first example. We have a diagram. CB right here is tangent to the circle. We know that AB, which is the radius, is 5 inches, and CB is 8 inches, and we need to find this length A to C. Now remember, if this is a tangent line, C to B, that means this is a right angle. So it intersects that spot with the radius at a right angle. Well, that would make this a right triangle. So we have this length, and we need to know this last length. So we can use the Pythagorean theorem, a squared plus b squared equals c squared, to find this last piece, that hypotenuse. So we just plug in the pieces we know. We would call this one our a value, this one our b value, and here to here is our c value. And I'm just going to write it in as AC over here. So 5 squared plus 8 squared equals this value from A to C squared. Simplifying that, 5 squared is 25, 8 squared is 64. That still equals AC squared. 25 plus 64 is going to be 89. That, again, still equals AC squared. How do we get rid of a square over here? Well, we have to take the square root on both sides, and when we do that, this cancels out with this square root, so it just leaves AC, which means then AC is the same as the square root of 89, and that's approximately then 9.434 inches. So that would be the length AC, this piece right here. Find the perimeter of quadrilateral ACEG. So remember, the perimeter of any polygon of any kind of shape, you just add up all of these lengths on the outside. So the perimeter is basically going to be this one. I'm going to do this in red. This A to C. This C to E. This E to G, this last G to A. It's going to be all of these lines added up would make the perimeter. Now, we only know some of these lines. So, let's see, we know the green one here is 6. Oops, I don't want that. I wanted... There we go. Is 6. If this is 8 and this is 3, that means this one is 11. But we don't know any of these, and we only know this part is 4. So we still need to find some other pieces. Well, looking at this one, here we have a point that we have two different lines coming off from them, and they're both tangent to the circle, right here and right here. If this length is 8, that means this one over here is also 8. 8 from here to here and 8 from here to here. If this piece of it is 4 and this piece of it is 8, the whole thing is going to be 12. 4 plus 8 would make 12. Similarly, if this is 4, that means right here is 4 as well. So we know this part and this part have to be the same. This part and this part have to be the same, which means also then that this part and this part have to be the same, making this 3. If this one is 3 and the whole thing is 6, that means this is 3 as well, which makes this 3 as well. Which means we can find our last piece then by adding 4 plus 3 makes 7. So now we know each of these lines. This is 7, this is 12, this is 11, and this is 6. So we simply add each of those pieces up. 12 plus 11 plus 6 plus 7 in the end equals 36. So this perimeter all the way around the outside of this is 36. In this example, we are looking for the value of x. We've got a couple different lines here. We've got this line touching the point right here. We know that it's 6x plus 15. And then we've got this line starting right here, coming over to this way, and we know that that's negative 2x plus 37. Well, if we look closely here, this line is tangent to circle Q, and it's also tangent to it at this point, which means that these two red lines are the exact same length. Now, similarly, this tangent line, this blue one, is the negative 2x plus 37. It goes right here, but it also is tangent over here, meaning the two blue lines are the same. So the two red lines are the same, the two blue lines are the same, and right here we can see then the red line is the same as the blue line, which means that all of these tangent lines are the same length. So 6x plus 15 is the same as negative 2x plus 37. So to make that into an equation, we'd say 6x plus 15 equals negative 2x plus 37. Now we can just solve it like any of our equations. Add 2x to both sides, we get 8x plus 15 equals 37. Subtract this 15 from both sides, and we get 8x equals 22. And then divide both sides by 8, and we'd get x equals 2.75, or that's 2 3/4. So you can write it either way, decimal form or in a fractional form. Another example, we need to find x in this case. Now, again, notice how we have one point out here coming up to this spot, and this is tangent because it makes this right angle here. We've got this radius, which is 12, and it is, again, perpendicular, makes that right angle. And then we've got this line coming from the outside of the circle down into the center. Now, because this is a right angle, we know that the red line squared plus the blue line squared equals the green line squared. But we don't know yet the whole green line. Now, if we look closely, though, if this radius is 12, that means this length is 12 as well. And if this is 12 and this is 8, that means the whole thing is going to be 20. So now we do know the whole green line, we know the whole blue line, so we can figure out that red line. We set it up as a Pythagorean theorem, a squared plus b squared equals c squared. Plug in the values we know. X squared plus 12 squared equals 20 squared. 12 squared is 144. 20 squared is 400. Subtract 144 from both sides and we'd get x squared equals 256. Remember, to get rid of a square like that, we do a square root to both sides. Take the square root of this and the square root of this. That'll cancel that out and get rid of all of this. So this side is just x. And then we'd still have the square root of 256. So we'd say the square root of 256 equals x. And we can simplify that because the square root of 256 is exactly 16. So x equals 16 in this case. We're going to call it quits there. That was the end of our first video.